Assalamualaikum warahmatullahi wabarakatuh. My name is Noan Syaira binti Mat Aziz and my partner is Syekh Muhammad Alif bin Syekh Muhammad Mazlan. We are from Group 6 and we are going to present development of autonomous all-terrain vehicles A2TV, which is module steering, throttle, and braking with monitoring system. For the product background, ATV is one of the type of vehicles that are much lighter than other four-wheel vehicles, making it popular among expert drivers when taking corners. It is more challenging than rugged four-wheel vehicles, thus stabilizing the current ATV is more difficult. It's also hard for the user to monitor the usage of battery, voltage and current to prevent battery become flat. So, to reduce the number of injuries and death from ATV accident in the future, a wireless remote control using Cytron PS2 need to be developed. It will help to prevent the farmer from infected by the toxic gas or any health issue while carrying the farm tool. For the objective, manual control steering is hard because it cannot rotate easily and need a high force. So our main objective is to design, stimulate and fabricate a throttle module steering braking system of ATV. For easier the user to monitor the battery, so we decide to develop a battery monitoring system to measure a voltage and current. Then the third one, our third objective is to test and analyze proposed system to existing electric TV. For the benefit is it can reduce accident and injury. Then it can move to danger place without person on ATV. So the less affected for the ATV. Lastly, recording or monitor using camera. The user can monitor the ATV from far away. Marketability we target are agriculture, surveying, and education. Next, I will pass to my partner, Sheikh Muhammad Ali.
Okay, thank you, my partner Anis Shahira. Okay, I will present about the methodology and the material. Okay, the methodology that process through to build this ATV is the first step is we do the requirement and specification of the autonomous ATV. This is because we need to know what the requirement and what specification of the motor and the component that we need before we do this project. The second is the steering module and the steering module. We do the mechanical and electrical design. This is important because we need to know where the position of the steering and so the steering can move left and right without any error, and the position that suitable for the steering motor is connecting with the shaft because the shaft is easy to move left and right. After we design the electrical and mechanical design, we fabricate, assemble and testing the steering module. After we design the steering module and we fabricate, we assemble the linear actuator as our steering motor at the shaft. So after that, we test the steering and it work. Okay, the next is the throttle drive. We design the mechanical electrical design. The throttle drive is the main motor at the ATV. So we design so the ATV can move forward and reverse. After we design, we fabricate, we assemble and we testing the throttle drive. After we assemble and testing and assemble the motor at the ATV can move forward and reverse without any error. More than that, after we do the throttle drive, we do the design, development and testing battery monitoring system consist of the voltage and current sensor. In this process, we do the monitoring system. The monitoring system include the LCD, the voltage sensor, the current sensor. We use these two sensor and one LCD is because we need to know the percentage, the voltage and the current of the ATV battery. More than that, after we do the monitoring system process, the last process is we do the field test for the remote control ATV at FTKE lab at block A1. The system involving the remote control consisting RC console and remote camera. We do the test at the faculty of FTKE A level 1. We use the remote control to control the ATV, and also we use the remote camera to monitor the situation with the ATV. The material that we use at our project ATV is first the LCD. Second is the voltage sensor for monitoring for get the voltage value. The next is the current sensor for the current sensor measure. Next, our microcontroller, if we use the Arduino Mega 2560, we use the linear actuator as our main steering motor. The next is we use the MDD10A driver as our main driver to control the steering motor and um, the throttle motor. Next is the electrical brush motor as our throttle motor. The next is the PS2 receiver to receive the information from the transmitter, which is the PS2 controller, and the finally is the 12-volt battery. Okay, for the result and discussion, for the first result, we do the time taken for the middle to the turn left, the steering to turn left. The time taken is about 0.93. The next is the time taken for middle to right. So when the ATV position at the middle and the steering turn to the right, the time is about 0.9 second. And time taken for the left to the right. So when the steering is in right condition and uh, sorry, when the steering is at the left position and go to the right, it's about 1.49 second it take to move. Okay, next is the testing. The figure show the cornering testing. The first one is when the ATV is in the static mode, and the second picture it show the ATV move and do the cornering. And the lastly, the picture show the ATV is in cornering section. For the next test, we do is the driving test. The driving test that we drive is about 0.2 kilometer, which means it's about 200 meter. We do the test at the A1 level at the faculty FTKE by using the remote control and the PS2 remote control. After we test the ATV, we see that there are no error for moving and cornering to turn left and right, to forward and reverse. So we see that our TV is very good condition, and also we can monitor the level of the percentage of the battery, the voltage of the battery, and also the value of the current of the battery. Okay, for the next is this is our loop for the final loop, our product, the autonomous ATV. The first is 12-volt battery, 400-watt DC motor, the linear motor actuator with shaft position sensor as our serial motor. This is our remote camera. And this is the board that control that have the Arduino, the PS2 shield current sensor and voltage sensor, the MDD10A motor driver, and the LCD as our main monitoring system. Okay, this is the camera view for the ATV that we get when we test the ATV inside the laboratory. And this is the picture of PS2 controller, how we control the ATV using the PS2 and using the remote control camera. Okay, that's all for me, and that's all for my partner. Thank you. I will show you the video of our demonstration. That's all from us. Thank you.